Terra preta is an ancient soil from Amerindian populations, and we have our knowledge of biochar from these ancient soils.
Research into the benefits of Terra preta and biochar is one of the most exciting developments in science today. These benefits include enhancing soil fertility and virtually permanent carbon sequestration. Dr. Johannes Lehmann of Cornell University is one of the top researchers in this field.
A Cornell professor, the first professor in the Department of Geology in the 1870s, traveled to Brazil and came back with stories about Terra preta, wonderfully fertile soils on the banks of the Rio Negro. Terra preta is the remnant of previous occupations of Amerindian populations starting at about 7,000 years before present up until the arrival of the Europeans. These soils are very dark, black soils that are very organic matter rich, very fertile, crops grow vigorously on them. So the exciting aspect of that is that in an environment that otherwise features very infertile soils under primary forest in the Amazon, there exist these very dark, very fertile soils that prevailed over hundreds to thousands of years up to present time.
Although people may think that rainforest soils are fertile, they are actually among the least fertile soils on Earth. By adding black carbon or biochar to the soil, the Amerindians created Terra preta and greatly increased soil fertility. This allowed for sustained agriculture. Brazilian sites show these man-made soils are up to 2 meters deep and have remained fertile, biodiverse, and up to 70 times higher in carbon than surrounding soils, even after hundreds or even thousands of years, in spite of the intense rainfall and biological activity of the rainforest.
How biochar was created in the past to produce Terra preta is of course largely unknown. One way how this could have happened is using technologies that we also know from charcoal making, piling up biomass and under the exclusion of oxygen, smoldering or thermally decomposing biomass into charcoal or biochar. This could have been added to soil, and that is what we see today as Terra preta. And this technology can be carried forward. This biochar can be added to soil now and create these favorable conditions that we see Terra preta still has after hundreds to thousands of years.
Today we can create biochar using the process of pyrolysis.
During pyrolysis, biomass is heated above a certain point that it spontaneously decomposes into charcoal or biochar. The off-gases can be captured to generate energy. Typically about 50% of the biomass is driven off to create the energy. The other 50% are retained in this very durable form of carbon called biochar. And this biochar can be returned to soil, to the very soils where we obtained our biomass from, thereby creating environmental friendly bioenergy systems.
Biochar improves soil in many different ways. It retains nutrients for plants that would otherwise be lost by leaching or to the atmosphere. It enhances microbiological activity, retains water, and increases crop yields. Dr. Lehmann's student, Christoph Steiner, has tested biochar's effect on crop yield as shown in this recent BBC documentary.
Inspired by the ancient Amazonians, Johannes Lehmann's student, Christoph Steiner, decided to find out exactly what effect ancient slash and char methods could have. So he has planted a series of experimental plots, some with added charcoal, some without. The experiment is still not finished, but already the results have been amazing.
On this plot we see what happens if we follow the traditional slash and burn technique. After the first harvest already there's nothing growing anymore, and we have here now the third harvest. Here on this plot we applied mineral fertilizer, but that is not very satisfying. If you look on this, there's almost no yield, almost no grain. A family couldn't live on this. That is not satisfying yield. In comparison to a plot where we applied additional charcoal. Here we can see that the yield is much bigger, so there is corn. And this is a plot where we applied charcoal and mineral fertilizer. And this combination, last harvest we had an increase in crop production of 880% in comparison to mineral fertilizer without charcoal.
An 880% increase in yield is almost miraculous. Charcoal seems to hold the nutrients in the soil, preventing them from being washed away by the rains. It's a simple trick, but one that Steiner believes could be the key to breaking the destructive cycle of slash and burn, and so reduce the pressure on the rainforest.
Unlike other organic matter that can be added to soil, biochar remains in soil for very, very long periods of time and offers the opportunity to truly sequester carbon in soil. If linked to a sustainable biomass production, the addition of biochar withdraws atmospheric carbon dioxide and locks it up in the soil for very long periods of time. The very interesting aspect of pyrolysis with a biochar return to soil is that by producing the energy through pyrolysis, you retain about 50% of your carbon that you invested in producing the bioenergy in this very, very durable form of biochar. That means that half of your carbon cycle that you would normally return to the atmosphere, you can divert into a much slower cycling biochar cycle. And that creates the opportunity to design a bioenergy system that is actually not only carbon neutral, as most bioenergy systems claim to be, but actually carbon negative. So this creates an opportunity for bioenergy to be carbon negative.
If bioenergy systems can be carbon negative, then producing biochar may be one of the most effective ways to fight global warming.
Biochar technology, even linked to bioenergy production, can be realized on multiple levels. It can be done on very, very small level. There are small ovens and stoves, cook stoves available that work on this technology that are heating 1 pot of water to boil your rice, as well as on large power plants that would power a whole industrial park or a small town. So this technology of biochar production can be realized in a small farmer setting as well as in large production systems. A biochar system is so appealing to both the politicians as well as the farmers as well as the scientific community because it is a comprehensive carbon management tool that helps alleviating our energy problems as well as managing our infertile soils as well as contributing to the mitigation of climate change.
How can biochar help to solve the problem of climate change? If we enrich the soil in all the world's cultivated farmland with biochar, we could remove and sequester all of the excess carbon dioxide in the atmosphere. The ancient terra preta soils of Brazil have inspired today's scientists and farmers to see biochar as one of the most promising ways to combat global warming and improve soil fertility.